Commute. Folks, welcome back to Indaba Africa. This is Chris once again. Hey folks, welcome back to Chris Wide Africa. It is Monday, June 28th, 2021 here on YouTube. And wow, I'm really stoked about this. My special feature guest today is none other than Dr. Jani Radebaugh, who's out at BYU, Brigham Young University there in Utah. She's a planetary scientist, and I'll do a better introduction in a second, but I want to greet her because she's probably going to get bored with me doing all these introductions. Dr. Radebaugh, how you doing out there? Oh, see, I'm having a hard time getting the mute off.
There we go. I'm doing just great. Thank you, Chris. Thanks for having me.
No, it's my absolute pleasure. Really excited to have you on here. So let me just run through some of the hit list here. I wrote a few notes down to make sure I missed this. So, of course, you were involved with the Cassini mission. You're involved with the Galileo mission back in the day. I mean, that's going back a ways. You've been involved with New Horizons, if I'm not mistaken, which, by the way, it shouldn't be a big secret to my viewing audience. My favorite mission. Yes, Pluto's a planet. That's Pluto's a planet, Dr. Tyson. Where's he at? Where's Neil deGrasse Tyson at? Anyway, but you've been involved in an awful lot of this. But, of course, as a planetary scientist, you've traveled all over here, right here on Earth, on our own planet, just to get a feel for what it's like potentially on other planets and other moons and other objects out there in space. I could go on and on. You've done an awful lot of stuff, but some really exciting things hopefully we'll talk about during this conversation is Cassini, and maybe Dragonfly will come up, and I don't know, you probably want to talk about the Mars mission. I don't know, are you involved in the current Mars mission at all with the Ingenuity helicopter and all that stuff?
I am not, but it's so exciting. I just can't believe the images and even video. I mean, we got video back from Mars. And a friend of mine pointed out that, I mean, this is because we've got lots of things orbiting Mars, so they can take the uplink from the spacecraft and then send it down to us and a fire hose. And so that's just like, a new day really at Mars. We're able to study it so well. And so I just am a fan. It's exciting.
Well, I'm with you. Listen, as a former Army officer, I spent a lot of time in aviation. We had helicopters, and I've got hundreds of hours flying in helicopters. And of course, the helicopter stays in the air with a thick atmosphere by beating the atoms into submission. I mean, it's kind of counterintuitive how you keep it. So when you think of Mars with 1% of our atmosphere, this is an incredible achievement, which I think people that don't pay attention to space really ought to recognize. 1% of our atmosphere, and this thing flies.
Yeah, exactly. I mean, I think it was something like 2,600 RPMs or something, to spin the thing and be able to get it up in the air, decently long blades, just because Mars's atmosphere is not like Earth's. And there are a lot of comparisons we make between Mars and Earth, and we say, gosh, Mars is so Earth-like. And there are in so many ways, Mars is not like Earth. It is, this thin atmosphere. It's a very cold, forbidding desert. It's not got a magnetic field to protect you when you're visiting, and low gravity. There just are a lot of obstacles to being able to explore Mars. And so it's amazing that we've been doing as well as we have.
Well, I mean, absolutely, and you make some fair points there about Mars. I mean, people think about it; it's not at all like Earth. I mean, as you mentioned, they don't have that magnetic field. That magnetic field long ago went silent on Mars, and if it had an atmosphere and it had surface water, that's all been stripped off. Imagine standing there without a protection of a spacesuit; you'd be stripped off pretty quickly there too from the solar wind. It'd be pretty rough on a human.
Yeah, exactly. And and the other thing you mentioned, it's very dry, and it's drier than the driest deserts on Earth. And in fact, colleagues and I go visit very dry deserts on Earth to try to better understand that environment so we can apply it to Mars. But always in the back of our head is like, yeah, but this is still Earth, and it's still, we've got this thick atmosphere. We've got, even if we go to a very high altitude desert, it still has humidity in the air. And we just don't have that at Mars. And so just keeping that in mind, that this is the driest of dry deserts. And that makes it really special.
Well, that's a good point. You've actually been to a number of these places. So we'll talk about the Namibia, of course. So we got a large Africa-based audience on here. And the Namib Desert's very dry, but that's a misleading thing because those winds bring in moisture in the morning, and you have lots of forms of life that are able to capture the dewdrops and survive just from that water. You don't have that on Mars.
No, exactly. Yeah, that's probably a big driver for differences in landforms even that we see on Mars compared to on Earth. Even though we do see a lot of things that are very similar. I mean, you look at pictures of Mars and it looks like the the backyard in Arizona, right? I mean, there are dry river beds and lots and lots of sand dunes everywhere, lots of dust. There are lots of even wind-carved ridges, and that's an area that a colleague and I are studying, are these ridges or landscapes that are actually carved by wind and not just blown there by wind like a sand dune.
So a lot of discussion, or a lot of this exploration takes place on the surface of Mars, is all related to looking at the influence of water or fluids on the surface of Mars at some point in the distant history, which is no longer there. Are we just being hoodwinked? Is it not really water? Maybe it was wind that caused all this, or is this erosion really the result of ancient lake beds and water sources?
Yeah, there are even some features. There are gullies along the sides of craters that could potentially be caused by movement of carbon dioxide frosts or ices. Big blocks might break loose and then rush down the hill. And some colleagues and friends have done experiments to sort of like ice block race down hills of dunes just to see what that would do and if it would make these gullies. And that's a possibility. I think that for the very well-developed river channels and, that have dendritic networks collecting into one main trunk, and then they distribute out into these large deltas, that's, in my mind, very hard to do unless you're using liquid water. And that's kind of protracted existence of liquid water on the surface in that location. The dendritic collection channels, boy, that's lucky if they all erupt out of the ground in those individual spots. In my mind, it's much easier if there was rainfall in the past. And so this is the long past. We're looking at the heavily cratered terrains and the highlands of Mars. These are old terrains. And in the very young regions, we don't see these kinds of things. So this would have happened for Mars very early on, back with a thicker atmosphere.
So years back when Pluto was delisted as a planet in our solar system, and made a Kuiper Belt object of some sort, but a lot of us were angry, and even if you weren't a Disney fan, you were angry. I'm one of the angry people, but as a layperson. But when New Horizons arrived, and we saw, by the way, I'm sure it wasn't just the folks who built the spacecraft and who built the software who flew this thing for years out towards Pluto, and then the whole operating system, like Microsoft's blue screen of death, crashes on them. I'm sure we were also pulling our hair out, like, no, we waited so long for this. But when it approached, they managed to reboot the operating. It's like Microsoft, just turn it off, turn it back on. But they managed to get out there, and the images have started coming back. I mean, I'm sure that people involved in space exploration and the people involved in the New Horizons mission were just over. I've seen Stern. He's so giddy over this still. It's just awesome. I ought to interview him. He's an amazing guy too. But
he's fantastic. Yeah,
he's fantastic. But the thing is that, listen, we were told it wasn't a planet. It's a dead world. There's nothing to see here. That was so wrong. There is so much to see on Pluto. And it looks like, I mean, obviously, you can talk about this if you like, but I mean, looking at it, it looks like there's geologic activity on in the recent past within the geologic history within the past 10 million years or so. Did I miss something, or am I just overly excited about Pluto?
Oh, no, you're absolutely right. And in fact, there was a flyby of Ceres, which is an object in our asteroid belt, right? And then a flyby of Pluto, and they were, within a couple of years of each other. And I had completely flipped those in my head. I thought, Ceres will have all these active things going on, and beautiful, crazy landscapes. And Ceres, it turns out, is very cratered, and it makes sense when we think about the history of Ceres that perhaps it started with a thicker kind of ice component that gradually got whittled away, and then everything just got bombarded over time. Whereas Pluto is sitting at a location in the solar system out there at the edge of the Kuiper Belt where the temperatures are very cold, and the ices present actually respond and move around and are active at those temperatures. And, before that, they were gases. So inward of that, they're just gases. They don't do anything. But closer, they're at this cusp between, well, sometimes we can be a solid, sometimes we can be a gas. What do you want? Bring us a little closer and we can do this. Bring us a little farther out, we can do this. And that just makes for a fascinating landscape and geology.
No, absolutely. And it's it kind of turns everything, at least that the layperson knows about science and physics, kind of upside down. I mean, you're thinking everything would just be frozen, nothing would happen. But we've heard descriptions of this like boiling gas out there. It's kind of strange. I mean, but you look at it, it looks like a resurfaced of that big heart-shaped portion of Pluto. It's amazing.
Yeah, now we're thinking that big heart-shaped region is a glacier, and this glacier, moves and flows. It's like toothpaste. It just flows in and around these very rigid mountains, and the mountains that are so tall and rigid there are water ice. because it's so cold that water ice is solid as a rock. And but nitrogen, nitrogen, what is that? That's a gas, right? It's our atmosphere. But out at Pluto, sometimes it is a gas up in the atmosphere, and other times it's collapsed down into this massive glacier that we think fills a really large ancient impact basin. And so now you've got this kind of history painted in your mind. And not only that, what I studied, I kind of came into it, the mission a little bit late, and just had conversations with people about this. What I studied with some colleagues is, hey, on top of that glacier is a set of parallel ridges. And I looked at those, and a couple of us said, gosh, those are dunes. Those are sand dunes. And everyone's like, what are you talking about? How can there be sand dunes on Pluto? And I kind of do what I do with the other things I study. It looks to me like a sand dune. There are very characteristic things about this. It's, they're kind of in a great orientation from the mountain. The mountain could have brought winds down. They're kind of disrupted in certain ways that are just like sand dunes. They get coarser in the middle, just like the middle of the sand dunes out in Mesquite Dune Flats in Death Valley, California. Just things I'd seen before because we're out in the field and looking at these things. And sure enough, it turns out when we started searching and we got all the New Horizons team involved, they said, yeah, there's some snow of methane snow sitting on the ice caps, the tops of the peaks of the water ice mountains up there in the interior. And if the conditions are right, those things could get lofted and then blown down across the glacier into sand dunes. So these are made of methane sand on a nitrogen ice glacier. And they look just like Earth. And that's what's so baffling about it.
It is. Well, I suppose if I could sell futures now for when the sun becomes a red giant and expands, I'm thinking that Pluto might be some nice location, beachfront property out there, but a few billion years down the road from today.
Yeah, I've got my eyes on a property right next to the glacier. So yeah,
exactly. It'll be lovely. Trust me, it'll be lovely. But it's funny you should mention that because unless I'm mistaken, is one of your favorite moons or one you've worked with or you're working on is Titan as well, correct?
Yeah, Titan, moon of Saturn. Yep. It's actually larger than Mercury. So and this is what's kind of interesting about the planet, not planet thing. I already had warned, the fact that the objects that I study are moons, they're satellites, they're not even planets. So I kind of don't care either way. They're still interesting no matter what we decide to call them.
But, but isn't Titan, isn't that the moon that has like lakes of hydrocarbons on it? Isn't that, I got the wrong name. Yeah.
No, exactly. And so on Titan, this is close enough to the sun. This is just 10 times as far away from the sun as the Earth, whereas Pluto is 30 times as far away from the sun as the Earth. And at that location, 10 times as far, nitrogen is still comfortable as a gas. And so the atmosphere of Titan, which is the same pressure as Earth's at the surface, and that's kind of an interesting thing to wrap your mind around. Gosh, I wouldn't need a pressure suit if I were an astronaut on the surface of Titan.
You just need something to breathe.
Yeah, something to breathe and a very warm coat. Nothing can be exposed because it's still just 90 degrees above absolute zero. And so it's cold, but the atmosphere is comfortably nitrogen and just sitting there. And there are lakes and seas, but these are lakes and seas of methane. Which we just said is a sand out at Pluto.
Yeah, exactly.
Or an ice or whatever, but here it's a liquid. It's very comfortably a liquid. And so there is a methane cycle, a hydrologic cycle where there's evaporation off these seas, there are clouds, there's rainfall onto the surface that's active today. And there's no other body like that in the solar system except for Earth that's got rainfall onto the surface. And it runs through rivers and it reaches lakes and seas and starts all over again. It's really amazing.
Well, I think Titan is the only other body in our solar system that's confirmed to have surface fluids on it. Is that correct?
Yeah, that's right. That's right. And so unless we can think of any of these, the glacier on Pluto is kind of being a fluid, but to be like a liquid, just like water. That's right. It's the only body.
Well, okay, I'll let the secret out now. I'm sure, maybe you're curious, I don't know, but can you guess which my favorite moon in our solar system might be? Just take a guess.
Well, I guess I'll just have to ask you if it's Titan.
No, it's not. It's not Titan. It's not Titan.
Our moon, Earth's moon.
No, it's a good guess. We should be grateful we wouldn't have anything going on this planet without our moon. Thank goodness it's there for the tidal action. No. It's perhaps Titan would be mine if I was invested heavily in hydrocarbon companies. I might get involved, but no, it's actually Enceladus. Enceladus.
Enceladus is fascinating. Isn't that a neat story that, so with the Cassini mission, and I kind of came in late. I was a postdoctoral researcher. There's a whole wave of us that came up. We call ourselves Cassini babies because we came in and started working for all the, the science team members at the time. And that really has molded our career. I think all of us could work the rest of our lives on Cassini data and be okay. But apparently what happened when Cassini first arrived is they flew past the location of Enceladus, and there was a really strong signature in the magnetometer data. And so Michelle Dougherty, who was at Imperial College in the UK at the time, I believe she might be South African, I forget. And I know you've got a lot of South Africans on your call. But anyway, she said, oh, I've got to go fly to Jet Propulsion Laboratory and bring some squiggly lines and show people, hey, we really should fly past Enceladus again and see what's going on. And she said, there's no way they'll believe me. Who cares about a squiggly line when you've got pictures of Titan to come back, And sure enough, they were like, yeah, okay, we'll look again. And then we saw geysers, volcanoes of water gushing out to space. I mean, it's just amazing and thrilling. And we'd never expect it because it's so small there.
And I think they found like amino acids, the precursors for life.
Yeah, exactly. Yeah. I mean, someone said, it tastes like comet or something was the comment. So, I mean,
it's the tiger stripes, the color, it's the brightest object in the solar. It's just, other than the sun, obviously, that's kind of brighter, but but let's not look at the sun. We'll avert our eyes, but we'll look at Enceladus. I think Enceladus, what was Enceladus? I think Galileo might have found it in 1610. Or maybe I get that wrong. Maybe I get the wrong.
Oh, I forget. That's me,
There's a question. Somebody in the viewing audience can look that up. When was Enceladus discovered?
Well, I know it's part of the E-ring. It creates the E-ring, so maybe they could count that. If you see the E-ring, you've kind of seen Enceladus, but I don't know if that's where that came from.
So let me ask the question. My favorite moon. What's your favorite moon in the solar system?
Oh, that's so hard because maybe
I know it is. That's why I asked the question.
You would probably say Titan, and there are fascinating things about Titan, but probably my first love really was Io.
Oh, I knew it. Oh, it's the ugly moon. It's an ugly moon.
I know. Yeah, I mean, so it's the pizza moon. We always have a pizza gathering when we go to conferences and get together. It's tradition. The Io group is usually kind of small compared to other, Mars especially. But we're really tight, and we really defend our moon. And I mean, it's hard for us, we say, why doesn't everybody love this place? Because there are hundreds of active volcanoes erupting on Io, dozens erupting at one time. And we can even see that from the Earth, from Keck Adaptive Optics telescopes. You can see the individual bright spots on the surface of Io, which is the same size as Earth's moon, at a distance of 5 times as far away from the sun as the Earth orbiting Jupiter. And I mean, it's just fascinating that there's active eruptions happening. So I love it for that reason.
Fair point, but the images of it are not nearly as sexy as Enceladus. I just have to say.
Yeah, I guess that's true.
But I suppose if you're a planetary scientist, if you're looking for geologic activity, Io's got a lot more going on. So that's the reason.
Yeah, you're guaranteed to find it at Io.
So I'm sorry. Go ahead.
Well, there are even there are mountains, and there are landslides probably happening from all the earthquake activity associated with the volcanism. So there's a lot of things going on.
Well, I mean, look, Enceladus has volcanism, it has cryovolcanoes.
Yeah, that's true.
Not exactly my favorite kind of volcano either. I wouldn't want to be underneath either one of those. But so these this volcanic activity on Io, is this a consequence of gravitational tug from Jupiter, or what causes it?
Yeah, it's a combined effect of the fact that it's so close to Jupiter. It's orbiting fairly close. And Jupiter's really massive. We forget that we can fit all the other bodies in the solar system, including Saturn, inside Jupiter and have room to spare. So it's big. And Io orbits close, but then also it's in a resonance orbit with Europa just outside of it and Ganymede just outside of that. So for every one time Ganymede goes around, Europa goes twice and Io goes 4 times. And what that does is it keeps the orbits elliptical instead of circular. If it's circular, and you're close to the body, you kind of don't care. You're just kind of stretched into one size. But if you get closer, you get stretched even more. If you get farther away, you relax into a sphere. And so this stretching, relaxing happens on Io every 40 hours. And it's something like 100 meters difference. So there's a tremendous amount of friction in the rocks in the interior and melting and volcanism.
Wow, that's unbelievable. So that stress from the bodies pulling and tugging against is what causes this.
Yeah, that's right. The bodies are keeping the orbit elliptical. It's Jupiter that's tugging on Io and causing that internal heating that's going on.
So, sorry.
Well, we think this could go on indefinitely. So this is another kind of beachfront property idea, is that, okay, this orbital resonance that we call, that orbital dance that they're doing seems pretty stable, and it might go on for billions of years. And so the sun goes red giant, 5 billion years from now, it disappears, it makes a white dwarf, and we're still left with this tidal heating going on inside. And just recently, an article came out that suggested that there should be seafloor volcanism on Europa. And so you have seafloor volcanism, you have water overlying it, you still have the volcanic eruptions on Io. Maybe this is where we all end up moving, right?
So when all the stars burn out and all the gas has been exhausted and we can't generate new stars and we don't have new supernovas and all this stuff, then I guess there'll still be a chance for life on Io if it's stuck in this perpetual.
Yeah, and that's just some mechanics, right? So as long as the mechanics can go on, that's a really interesting idea.
That is crazy. So Bosch Deborah looked it up. He got to the world-renowned source of information, Google. So he said that Herschel. I think I said Galileo. I was Titan.
That makes sense.
Because Titan's so large, Galileo saw it back in the 17th century. Herschel found Enceladus in 1789. That's what it was. Yeah. Okay.
Nice.
So you traveled the world. You've been to Antarctica. You've been to Iceland. Now I've not been to Antarctica, but I've been to Iceland. I absolutely love Iceland. You've been to Namibia. I've been to Namibia. I love that place. You've been to Ethiopia. I'm agnostic. I lived in Ethiopia, but you probably saw.
Oh, did you?
Yeah. I've lived all over Africa. I've been in Tunisia, Liberia, Botswana, Malawi, Nigeria, Mauritania, awesome. Uganda, and Ethiopia. So yeah. But
I've also been in Tunisia and Egypt.
You've been in Tunisia as well. Okay, cool.
Yes, a long time ago, 2009, I believe we went there for a meeting and got to visit all of the chats, the depressions, their salt flats. But when we were there, they were all flooded. So we had planned to kind of walk across them, but they were all flooded. But we did make it to all the Star Wars sites. And in fact, we have a paper that suggests, so we visited, I think it was Mas Espa in Tunisia. And at Mas Espa, we noticed, gosh, there's a large sand dune that's sitting right on the edge of Mas Espa. And you know what happens with sand dunes is that they move. Right. And so we said, what's going on with the sand dune? He said, this wasn't here earlier. It's kind of coming close to the set. And we found a different set, Luke's boyhood home, that had been overrun by a sand dune just up the way, and it completely destroyed it. And this is a big tourism site for people in Tunisia. So we actually looked at satellite images and found the migration rate of the sand dunes. It's a paper led by Ralph Lorenz. Mm-hmm. And as the sand dunes migrated, we figured out, okay, in just a few years, it's going to reach the edge of the buildings and start to cover them. And this actually led to the ammunition for a campaign to go and bulldoze the dune out of the way. So they did that. And so it's sort of a short-term solution because there's more sand coming, but at the same time, hey, they saved Mas Espa. It was a really, really awesome effort. So
that area is pretty amazing. I've actually stayed in the hotel, which is supposed to be the house where he and his parents. So there's his uncle.
Oh, that's so neat.
There's hotel rooms. I mean, they took the rooms and turned, but it was in the wintertime, and boy, it's cold down there.
Wow, and I guess the desert gets very cold in the winter.
Yeah, well, there's no electricity in the room. It's just carved out of underground there, and you can look up and see the stars. And then that area near there, it's like, it just reminds me of gumdrops, all the little hills that are around.
No,
it's beautiful.
It's such an alien landscape. It's really beautiful. I think that is another good analog for some sites on Mars that we would find, areas that are carved out by wind, initially by water, and then the wind has shaped them. I think there are a lot of regions like that on Mars. Is that what you thought? This is Mars?
That's what I was going to say, is that when people ask about it, I tell I've been there, they're like, oh, what's it like? I said, well, it kind of reminds me of the surface of Mars when I think about it, because those hills are kind of red too in some respects. And I always saw the surface of Mars, but interesting place. But I like Star Wars, but it wasn't my favorite, but especially the later movies. The first 3 were pretty good, but it was pretty cool to go to that site. Pretty interesting location to go to. So now you've been in Namibia as well, in the Namib Desert. What were you doing down there?
Oh, I really love Namibia. The Namib Sand Sea is one of the largest sand seas of Africa, and that kind of makes it one of the largest sand seas on Earth. And it's a really interesting collection of sand that sits right out on the southwest coast of Africa, South Africa. It exists because there's a little bit of a low region and then a big escarpment that protects it from the rest of the continent. And sands come out of the Orange River, and then they just get carried up the coast by the currents, and they get kind of sent inland, and then the winds sort of trap it there. And it's just done that for thousands, tens of thousands of years, and built up into these large sand dunes. And the reason we like it is because the kind of sand dune you find there, and this is like the kind of sand dune in Egypt and all across North Africa, is called a longitudinal or linear dune. And they're very big. They're something like half a kilometer wide. They're spaced by a kilometer or two, and they can be hundreds of kilometers long. And we don't have any context for that in the Western US. We're used to these tiny little patches of dunes nestled in basins. And so this is the first time I'd heard of these is when we looked at Titan, because all across the surface of Titan are the same exact kind of dune. And they're even the same size and shape. And I think that's the reason. The reason for that is that the atmospheric pressure at the surface is exactly the same as Earth's. And so basically the winds and the atmosphere are the same, and they help to shape the sand into the same kind of sand dune. So we go to those areas because they're perfect analogs for what we see on the surface of Titan. It's really awesome.
Interesting.
Yeah.
Point. I can see why you do that. Now, of course, famously, the Orange River didn't just carry sand to the Namib Desert. It also carried diamonds from the
It carried diamonds. Yeah. In fact, we got to visit Rotorcraft Impact Crater, which is a beautiful impact structure. It's just, I think, 3 kilometers across. And it's flanked. It's got dunes kind of piled up into them. So we went to study how the dunes interact with that crater, because we see a lot of that on Titan. So again, just a perfect little analog. But the paperwork to get into the Sperrgebiet was just, I mean, it took us an extra year for us to say, we will not go anywhere near any kind of river drainages and pan for anything. We're going to leave all that alone, we promise. So yeah. It's a difficult region to visit.
Yeah, well, for those who don't know, what Jani's talking about is the Sperrgebiet, the forbidden zone, has been that way for over a century. The Germans originally made a Sperrgebiet, hence the German term for it, Sperrgebiet, because the Orange River, which comes down from the Highveld in South Africa, flows down to the west into the Atlantic, where it's hit by the Benguela currents, which are great for fish, by the way. But it's great breeding grounds for fish. Lots of nutrients there created by those currents upwelling. But those currents upwelling also carry the sand, as she talked about, and it carries the alluvial diamonds up along the coast, and they spread out over hundreds of kilometers, and over eons they've just washed ashore. And you literally, if we went back, say it's like 1880, you could be walking along the beach there in Namibia and go, oh look, what's this, a diamond? You'd find them all the time. They have these huge ships that go, they're like ships that come out there, and they just dredge, and they've been doing this for decades and still turning up diamonds, quality gemstones. So that's kind of what we're talking about. But the Namib is absolutely amazing. Now this is not a science thing, but I'm going to ask. You don't have to answer if it puts you on the spot, if it gets you in trouble with any other planetary scientist. But did you do any quad biking or anything like that when you were out in the Namib?
We did not. I did quad biking in the United Arab Emirates, and that would actually be pretty neat in the Namib. But we did get out in some 4-wheel trucks and got way down into the interior of the dunes. That's what I love to do, is just get just as far away from anything as I can, and see the dune and the interdune and the whole region for what it is, and just kind of like, just primitive. And so we tried to do that. And then we kind of dragged with ourselves behind us a ground penetrating radar, which is just a little sort of like baby buggy sized instrument that just sends a signal down into the subsurface and returns it. And we can see the layering of the dunes. And that helps us understand which way the sand is moving along the dunes. And so that's a kind of exciting project. But let me tell you, it took us an entire day to carry that thing up to the top of one dune and down the other side of the dune. These are gigantic features, and they're kind of overwhelming. They're like little mountains off into the distance. They're so beautiful.
And what's shocking about it is it's absolutely almost devoid of vegetation, although there's some on the fringes of it. But elephants and Hemsbach wander through there and subsist and live in these environments. It's crazy. Now, it's on the eastern side, obviously not on the dunes themselves, but on the eastern side of the desert. It's stunning. Let me do a little bit of housekeeping here very quick, and I have a couple questions from viewers here. Folks, you're listening to Chris White Africa on the Indaba Africa channel here on YouTube. My special feature guest today is Dr. Jani Radebaugh from Brigham Young University out there in Utah. She's a planetary scientist who's been involved in so many missions. There are countless ones, but let's hit a few of the wave tops here very quickly. We'll talk. She was a Cassini mission, New Horizons. Back in the day, she was involved with the Galileo mission. She's done an awful lot of stuff, traveled all over, and since she spent time in Africa, we wanted to bring her on to talk about that as well as what she's currently up to. So thanks for tuning in. Now, a couple questions from the chat. Make sure I didn't miss this. Now, Arctic says, can we get Pluto back? Earth was fine until Pluto lost its planetary status.
all the fifth graders, every time I go talk to elementary, it's so sad. They say, what happened to Pluto? Where did it go? Is it gone? Oh no, I'm sorry. It's still there. We love it very much.
I suppose part of that must have something to do with the fact that they use a name that's associated with the dog character from Disney, and kids know that character.
The kids, yeah. The kids identify with it.
That's probably what it is. But let's see. So ZS3PV is from South Africa, says, are the spin and orbital angular movements, movements of planets related?
Yes, to some degree, everything responds to each other in terms of the gravity, especially everything responds to the sun and the sun's gravity. And so, of course, initially the sun was there and everything formed out of a cloud of gas and dust. And the planets obtained their initial spin because that cloud was spinning early on. And so as they coalesced, they also gained that spin and then preserved that. And there was something about as things collapsed that kind of helped give them their tilt with respect to the sun. But that can vary quite a lot over time. And it turns out Mars's tilt has varied quite a bit over time, and it's probably heavily impacted its climate. And so this is another reason why, Chris, as you mentioned, the Earth's moon gives us a lot, because the moon helps to stabilize Earth's tilt from, only kind of goes like this over time, and it avoids these really massive climate excursions that might have prevented life from taking a hold early on.
Absolutely. So, of course, the question too is with the moon, the gravitation with the rising seas and all the action that ginned up, allowing amino acids to coalesce and for life to actually get a start in the oceans is probably likely, many scientists believe, as a consequence of the moon actually in orbit with us. Without the moon, we may never have had that. We may never have had the oceans moving in that fashion.
Yeah, and it's a little bit, shocking, I guess, to remember back to the fact that the moon is a little bit of an accident. And it happened because, there was a Mars-sized object early on and then the proto-Earth, and there was a collision between them. There didn't have to have been a collision. They could have just narrowly missed. But with that collision, we gained a moon, and that was a really fortuitous event. So that messed us with our minds, because does that mean we need to look for a habitable planet with a moon, with, a sun-like star, all those things, because that's the only way we can imagine life having started, because that's all we've seen so far. And I think it'll be fascinating over the next few decades, if we do find life somewhere else, how that will help expand. It will just pry our minds open to, okay, there are other possible scenarios that can lead to life.
Silicon-based life, perhaps?
I wonder, yeah.
Wouldn't that be interesting? So Cameron Heslop, who's in South Africa, says, his favorite planet was Vulcan, but unfortunately it blew up. Now, Cameron, that's only in the crappy alternate Star Trek universe. That doesn't count. Vulcan is still there. I just thought I'd let everybody know that. So, and then we've got Mark Gardnier says, what does it mean when a planet goes into retrograde? I'm imagining it goes backwards, the opposite direction.
Yeah, retrograde is just our view of a planet up in the sky. It appears to go backwards just because of our vantage point changing as we're going around. Everything continues to go around the sun in its same orbit. And so as we look up, we see, oh gosh, it looks like Mercury's going backwards. It's just because we're in a different point in our orbit compared to where Mercury was. And so when we finally kind of grappled with, oh, hey, the sun is what's at the center of the universe, or the center of our solar system, and not the Earth, then everything fell into place. Oh, these are all circular orbits. It all makes sense now. So basically it's just a way for us to understand how we orbit related to each other.
So here's a question from me, and then you've got some interesting slides that we're going to put up here, or you're going to put up in a second. We'll chat about. But okay, best candidate for life of any form, whether it's a silicon-based life or it's biological life that we know of in our solar system. Do you think give me best candidate for it, in your view?
It's so hard. And I think if you ask any planetary scientist, they'll do the same thing. They'll kind of search their minds and I don't know. Could it be Mars because there was transfer of life between Mars and Earth early on? I really think that was probably happened. We got a lot of meteor strikes on both bodies, and we did have material delivered to Earth from Mars. We know that for sure. So could that have happened and then it got sort of sequestered underground and buried and hidden there? So is that either fossil life, or did it end up thriving in some locations? Could it be there somewhere? I guess that's a possibility. We even went back to the moon and we looked on the surveyor craft and found after 3 years that there was still bacteria alive on that spacecraft, even though it was in the vacuum of space. I mean, life is really resilient. So maybe you could find evidence of that buried somewhere hidden away on the moon. What about Venus? Now we're headed back to Venus. And was Venus clement enough in the past that there was something, oceans on the surface for a while before it got too hot, before everything vaporized up into the atmosphere and left? But there's a layer up in the atmosphere that might be comfortable,
where you could float live in the atmosphere.
Even now, yeah, it's like a cloud city, right? And it's at 1 bar atmosphere. It's at nice temperatures. Maybe there's a little bit of water in that location, and we've just seen this, tantalizing evidence of phosphine that's best organized, I guess, by life. And so who knows? Maybe that's a place for us to look. And we never would have thought of Venus, right? But I think and then you can go out to Europa, this moon of Jupiter, and say, buried down under this, layer of ice crust, and there's a liquid water ocean and a seafloor with volcanoes. And we know that's a site for life on the Earth that's independent of sunlight. And so maybe there could be these seafloor smokers on Europa that has life operating there. But that's down deep in a maybe 100-kilometer deep ocean. How do we even get there? How do we ever find that? That's a big challenge. And so then you look at it and sell at us, and you can maybe just capture it as you fly by and say, oh, yeah, here we go. Here's life. And that's really easy for us to think about doing, right? And to go and grab that. But I think really best bang for your buck is to go to Titan, because you have surface fluids of methane. I forgot to mention the sand dunes are made of organic materials. And I still can't describe very well what that means, because we don't know. Is it like a cereal on the surface? That's essentially the right composition and even color. It's like grape nuts for you Americans. Maybe that's what it is on the surface. But there's lots and lots of that, and it can interact with methane. And then the crust of Titan is made of water ice. And so you have a big impact event, and you melt all that water ice. You've got a slurry, a melee of water and organics on the surface. And this will happen whenever you have impact events. And maybe Titan is the place to go and look for evidence of life.
Sounds like a lot of possibilities. We just have to be very flexible in how we look for life. Yeah. But it's the thing is, I get so frustrated as a non-scientist, but someone that pays a lot of attention to science. Whenever I hear people talk, whether it's about climate change or something else, the science is settled. That flies exactly in the face of science. I mean, science, you propose a hypothesis, you test it, and maybe you were right, maybe you're wrong. Science we're constantly learning things, and when it comes to life, I mean, who would have thought that tardigrades could survive in space and then come? Tardigrades, and then these you talked about these black smokers deep in the Pacific Ocean and the kinds of life down there. We had no idea. The coelacanths thought to be extinct for 50 million years, and they find it in the Indian Ocean, and they find a bunch. So we're constantly our pre-thought, our preconditions, the mindset we have about so many things when it comes to life has been proven incorrect time and time again. So I think we have to keep an open mind about where life might be and what form it takes.
Yeah, exactly. And I think it's hard enough for us to imagine that. I think once we finally start seeing it, then we'll say, oh, yeah, here's where it is. It reminds me of visiting a site where there's an impact crater in Australia. And we knew it was an impact crater. Some others had discovered it before, but I wanted to see evidence myself. I wanted to find these rocks that would give evidence of it. They're called shatter cones, and they have this kind of feathery texture. Like if you've ever seen a blast hole on the side of a rock, you see that feathery texture. And I'd seen it in other rocks, and I was like, okay, I'm just going to look and look and look. And it took a couple hours, and finally I was like, oh, look at this. And we saw it, and then everybody else, oh yeah. And then we could start picking them up everywhere. Here they are. And we were certain that we were pretty good at it by then. But it takes a while for you to get used to it and to know what you're looking for until you see it. I don't know.
Well, there's a couple more questions that crept in here really quick. I haven't had a chance to read them. Let me pull those off, but I'll read this comment now, and if you want, you can put the slides up because I don't want you to blush or be embarrassed. But Christoph Havang, who's in South Africa, says, Chris, he's here for a few minutes. He said, Chris, you should have said the smart space lady is this beautiful. So, well, Christoph, a little bit of bad news there for you. I believe that she got married recently. So
I did. I just got married just a year ago because of COVID, which is really interesting. And it's been fun. He's traveling around with me. And in fact, we just went to Iceland to visit the active volcano. I went with my colleague, Laura Kerber. She's at Jet Propulsion Laboratory. And she's the principal investigator of a mission to the moon. It's called Moon Diver. It's really exciting. She'd be another fun person to have on. But the idea is to go roll up to the edge of a lava tube and drop yourself down into it. Isn't that fun? And so we knew there were lots of basalt cliffs all around the country in Iceland. And so we went and visited a couple of those to kind of do some analog studies. But also, we knew there was an active volcano erupting. And our friend Christopher Hamilton is over there doing a sabbatical just as this volcano erupted. So he helped us go out and see it. But it's just spectacular. But so we both brought our new husbands. We both got married in the last year. This is what COVID did, I guess, for world travelers, right? And so we said, yeah, we had to add a couple of extra rest days for our field work. And our husbands said, there were rest days. So anyway, just they're getting used to our mode of travel. But they were thrilled with what we saw. In fact, I could show you a video of a volcano erupting if you'd like to see that.
Oh, that'd be pretty cool. We'll get to
that. Okay. Maybe I'll start. I'll share our screen here with this. So this is a picture of Jupiter's moon Io. most volcanically active body in the solar system. And you can see this is just basically what your eye would see.
Ugly planet. I know it's a moon. I know it's a moon, but I still say planet.
It's a moon, yeah. The blues are a little more blue than your eye would see, but every black dot you see here is pretty fresh lava. And we think that a lot of them are in the form of lava lakes. Here's a big lava lake on the right. This is from Galileo, so it's close up. And this is like about 80 kilometers across, 50 miles across, and it's a depression filled with lava on one side of it. And on the left, you can see Earth images. All those bright dots are actively erupting volcanoes. We can see from the top of Mauna Kea in Hawaii, which is just incredible. The one on the lower right is a Galileo image, just to show you where everything is.
Now, to be fair, we got to let people know you've also had some tough duty too. You've been to Hawaii as well.
I have been to Hawaii, yes. In fact, I love Hawaii with all my heart. I was so sad because the 2018 eruption finished 11 hours before I arrived on the scene. And so I didn't get to see any of that, although I did get to go out with them and look at some steam vents and hot cracks and help to map that. I helped the USGS with that, which was really thrilling. So anyway, we heard about this Iceland eruption, and we really want to understand the style of eruption happening. And so I bring cameras to take, images and turn those images into thermal images so that we can understand how hot it is, what style of eruption it is, and compare with Io. But we got so lucky, and I got a flow right next to, the road. I got to go look at it. But this is the video of my life.
Oh, wow.
One night, and it's the fountains you see are hundreds of feet high.
Wow.
And a river of lava.
Now that's this year's eruption, correct?
Yeah, this was in May. It was on May 26th or something of 2021.
That's unbelievable.
And then look at the little pond forming here as it trickles out and it flows out across the landscape. It's just
wow, just molten rock.
I think I just said it's so beautiful it hurts. I remember saying that. Anyway, it really was.
So can you go back to the photo you had a moment ago after you finished?
Oh,
this?
yeah.
I just want to see it real quick. So look, Jani, I'm not a planetary scientist, and I know that flow rates matter, but aren't you standing a little too close to that lava?
I know. Everybody sees this is like, what are you, crazy? I did watch it for a while. And while it's moving pretty fast, it's kind of like a slow walk. That's the speed of it. And of course, it is just coming out. You really shouldn't turn your back on lava. I should add that I did have my husband's eyes on the lava. I was trusting, I don't know, maybe too trusting that he would tell me if it came too close. But yeah, it's like the ocean. Don't turn your back on lava, really.
Just some advice for folks.
Yeah, don't turn your back on lava. I'll show you one drone. We did get a little drone footage. This is right before we lost Laura's drone across the lava flow field and had to run after it and get it. But there were these.
You recovered it then.
We managed to recover it, and I don't know how we did. I mean, it was about a 40-minute, trot over there. We relied on the drone light staying on, and then Laura had some binoculars, so she stayed on the hill and kept her eyes on the binocular on the drone, and also was looking for us. But this was kind of nighttime, and then I had a phone, so I was WhatsApping with Laura. Okay, can you see us? Can you see the drone? She's like, you're way too low. You got to go up to the right. You got to, So if it hadn't been for all of those things, we wouldn't have recovered it, I don't think, but we did.
Wow.
Yeah, I just love the pond. Look at it. I mean,
what kind of on station time does that drone have? Like mine only gets like 20 minutes, and I got to pull it down and put another battery in.
Yeah, 20 minutes. And so she landed it a little early because she knew she wanted to keep the battery going. The light might last for longer. Like it did last that whole hour or so, just the on light. So maybe that's a feature in the DJIs to kind of say, hey, if you lose it, we'll keep the light on for a while.
Well, let me contact the Chinese. They're the ones that make them. Yeah,
exactly. Yeah. But we could hear drones buzzing all over the place. All those drone videos you can find on YouTube of them flying over the vent. I mean, it's an amazing place right now. There are lots and lots of tourists. If you have any inkling to go and visit, I would say do it. It's really spectacular. It's a lot of fun.
Well, I would recommend any time at all to go to Iceland. It's a fascinating place. I mean, it's literally ripping itself apart. I mean, the plates are splitting it. If you go to have you been to Thingviar where they held the Alting? You can see the Earth actually splitting right in half. It's unbelievable.
It's fantastic. Yeah, that's really moving to do that. Just to stand there and kind of almost put two arms, one arm on North America, one arm on Europe, and realize that this is happening right now. It's rifting apart. And then you can see it happening just, 100 kilometers down the road at the eruption. So it's great.
Well, it's also interesting for me because, of course, I speak German and English fluently. Of course, English being my mother tongue. And so I go to Iceland and they speak Icelandic and I want to understand it, but I just get so confused.
I always feel like if I just kind of, suspend my belief, then I can suspend the disbelief, then I can hear it. I can hear what they're saying. Oh yeah, they just said you should go to the store and get this thing. So it's very close.
It is. But my old Norse is kind of rusty, so it's a challenge. Well, those are awesome images, and I can see now watching the drone footage of the and watching the footage of the eruption there. I can see why you kind of like Io now. You might win me over here. You might just win me over. It's pretty impressive. I mean, when I think of volcanoes, I'm thinking of Krakatoa and Pompeii, and I'm like, run away. That's not for me.
I know. Yeah, those. I mean, I have a secret sort of. I don't know. I don't want to call it a hope, but that there's a super volcano eruption in some way in my lifetime. But we really haven't had one since humans have been around on the scene, at least, for the last, 10,000 years or so. There were some who, I guess Mount Mazama was like 8,000 years ago, if I'm remembering right. So I think there were some reports about what that was like a long time ago. That's up in Oregon. Mm-hmm. So yeah, I mean, it would send ash from Yellowstone all the way down to Louisiana because that's what the last eruption did. So it's pretty devastating, but it just would be incredible to observe. It'd be fascinating.
Well, listen, don't give up hope, but I would suggest this. You live out there in Utah, you might want to relocate because the Yellowstone Basin, according to that 2012 movie, that's the caldera is going to explode. The Yellowstone caldera might make your dreams come true, but I suspect it'll bury you under ash. So you might want to move a little further away.
That's right.
Look, I can see why you find it so fascinating. But can I ask you this question very quickly? Because what got you into this? I mean, what made you want to do this? I mean, were you interested in geology, or did you just like rocks when you were a kid, or was it weather? I mean, what inspired you to get into this? Because I know why I love space and astronomy. But what got you into this?
I think I was just sort of right place at the right time, and maybe just something innate. I don't know. I grew up in summers down by Capitol Reef National Park in Utah. And at that location, there's all the beautiful red rock sandstones with big basalt boulders on top of it. And so we played around in those things. I don't think I knew what I was playing in before, but it's interesting to me now that I study the dunes that made those sandstones and I study the volcanoes that made those boulders. And so, maybe it was like written in the stars from early on. But I think when I was 7, I went to the Smithsonian and saw this movie called Planet Earth. And I can still remember seeing that image of Earth from space in that movie. And I was just fascinated by that. And I think I had a little journal at age 7. I want to study Earth, or whatever. So I think that was the early planetary scientist in me. And then not long after that came Star Wars, Indiana Jones, E.T., Close Encounters. And I'm not kidding. Those fascinated me and just really instilled this idea of just adventure and exploration. And I just wanted to explore. And that kind of translated to be an astronaut if I can and go out and visit space. And now I just go out and do that on the Earth, which is exciting.
Well, we're of the same generation. We're both in our mid-30s at this point. So anyway, but no, it's the same sort of thing. Same thing for me. I was a kid. I was living in Maryland. They took us for a school trip to a planetarium, and I was just enthralled watching all the stars in this room above me, and that kind of got me going on. Of course, the Star Wars came up, but I didn't see it then as a kid. I saw it later. But all these things happening at the time, lots of fascinating things. We had the Voyager missions back in the 70s when I was a little kid, and it really got into it. Then I went to college, and I took astronomy. And I discovered that you have to have math skills, and that kind of put the kibosh on my career in astronomy or space exploration. It kind of put a finish to it. Actually, the ironic thing is that I learned a lot about mathematics and became very astute in investing. So it may not have served me well. It may not have served me well to become an astronomer, but it certainly served me well in other aspects of life.
That's great.
Yikes. So let me see how you get a couple of these questions, because you still got some slides that are really fascinating we want to get to. But I wrote these down. Folks, if I miss your questions, my apologies. I'm doing the best I can get them in here. But let's see. ZS3PV says, does the evidence of methane, can it be people, they're typing is, it's a challenge for people to type in these little chat windows. So I got to put this sentence, it's kind of messed up. Does the evidence of methane, can it be related to the presence of methanogens under the planet's surface? What's a methanogen?
I am not actually completely sure myself. Methanogens.
I know what a methane hydrate is here on Earth, but I don't
Yeah,
know
exactly. Yeah, that's what I was going to say. That we do think that some of the crust might be made up of these methane clathrates, which are like a cage of methane around some water, and we have that down in maybe it's the opposite. No, I think it's methane cage around water. We have that on Earth's seafloor, and so sometimes when we really disrupt the seafloor, we release a bunch of methane out into the atmosphere. And so there was some notion that, well, maybe a lot of Titan's crust is made up of these methane clathrates, and that could well be true. We think there's a really significant methane groundwater table all throughout the crust. But one thing that's interesting is when the methane goes up into the upper atmosphere of Titan, it gets broken apart by sunlight, and it recombines into longer chain organic molecules. This is where the sand of the sand dune comes from. It's like a snow that settles to the surface. The word we use is tholins, and this was coined by Carl Sagan early on. And so those materials go to the surface and they get hardened into rock, they get eroded into sand and cobbles, and then the sand gets blown into dunes. And so you have to continually supply this methane, and we think it's being supplied from the interior, deep down in the mantle, in the core, and through volcanism. So that's another idea. What do volcanoes look like on Titan? And are they water volcanoes because you have to melt the crust, which is water? So that would be a cryovolcano, but maybe the gas that powers it is methane or nitrogen. That's another idea. So there are a lot of landforms that could be volcanic in origin on Titan that we're keeping in the back of our minds.
That's fascinating. I should add, since you mentioned Carl Sagan, of course, I'd be remiss not to mention that Cosmos, the original Cosmos, and Carl Sagan, clearly a huge influence on me as a kid, inspired me immensely, really, really did. I mean, I grew up in all kinds of circumstances, but when I first saw Carl Sagan on TV, I was living in abject poverty, and I thought of a bigger world of greater possibilities just because of Carl Sagan. So pretty awesome. He was a great light out there. So.
I agree.
I know they inspired Neil deGrasse Tyson, and he got a good meeting with him when he was a young man, which is pretty cool. So,
oh, wonderful.
Yeah. That's Neil deGrasse Tyson's got an interesting story. So maybe one day I can get him on my program. We can talk about that.
Yeah.
So
wonderful.
Rebellious Ruth is asking, does your guest know anything that they've discovered on other planets can benefit Earth? Well, I mean, if we keep burning hydrocarbons, Titan would be an endless supply of power. But I'm sure there's other resources within the solar system or maybe outside our solar system that are of great value. I know that there's a serious effort now that this isn't science fiction, mining asteroids, really tethering an asteroid and mining it. We can find limitless resources there. But before you answer that question, this is always my concern. The Earth is always being bombarded every day by tons of stuff from space. It comes down, either evaporates, but it adds to the mass of Earth. Are we in danger of mining things from space and slowing down the rotation and messing up our climate?
Oh, that's interesting. Yeah, I think there is a very minuscule slowdown because of that influx, but it's many tons of material a day, so it's not like it's not negligible.
Yeah.
And we ought to think about that. And yeah, I think it's so fascinating that there are a couple of asteroid mining companies out there that are in the black. They're doing well. They're investing in other things right now and getting ready because. Still, I think it's still that if you spend $1 billion, you can get $1 billion worth of stuff back from an asteroid. But hopefully it will get a little better and you can get more of a stream coming back. But it's that, all that stuff is just sitting out there on the surface. It hasn't been concentrated into the core like on Earth where we've lost it. We just have to go for the trace stuff sitting on the surface. And so you go to an asteroid, you can get to it easily. That's exciting. I would say that our biggest, we can learn some good lessons from our nearest neighbors. And so there's Venus and there's Mars. And really it is a Goldilocks story. And, we have on Venus, it's much too hot. On Mars, it's much too cold. On the Earth, it's just right. And the story is not that simple. It turns out that Venus might have been really kind of clement early on. It might have been more like Earth. It's not just that it's orbiting a little closer to the sun than the Earth, but there might have been some other things in there that caused its divergence from the path that Earth took to make it more habitable. But for whatever reason, the carbon dioxide wasn't pulled out of Venus's atmosphere. And what helped to pull it out of Earth's atmosphere was the advent of life. Oceans were doing it first. And so the oceans helped pull that out and make it into rock, into limestone. And then when life came on, it did it even more vigorously. And so most of us can look up in the mountains nearby and see lots of limestone that was all made on the sea floor and its fossil atmosphere. And that made an atmosphere that's much nicer for us to live in. But Venus never had that happen. And so it's just got an atmosphere that's 500 degrees centigrade, and it's got the pressure of the Earth's ocean at 1,000 feet depth at the surface. It's a very difficult place to explore. Imagine living there. So that's a kind of one example of a runaway. And then there's the other example of a runaway, and that's Mars. And Mars is just too cold. It's, as we said before, it's a desert like Earth, right? But it's a very cold desert. And not only that, it's too small. Mars should actually be a little bigger. And it turns out that the migration of Jupiter probably messed that up and scattered all the other Marses and left behind just one Mars, which is too small. And so it's too small to have a liquid core, which means there's no magnetic field. And the magnetic field really protects life. It protects the atmosphere. And now we're left with a heavy radiation, low atmosphere, very cold desert. And so the more we understand about those bodies and the pathway they took, the more we understand about Earth and its potential divergent pathways into the future.
So has Mars never had a magnetic field? I thought that it had a small core, and then it kind of became solid very quickly, and it lost within a short period of time. And the other thing is, when that migration took place, did that stop the accretion of more mass onto Mars and kept it at its smaller size?
That's what we think. That the latter question you asked. We think there might have been some other Mars objects. This is part of what's called the Nice model and the grand tack theory, which is that Jupiter migrated inward and has scattered a bunch of objects in moving inward. And as we look at other solar systems, we see that just beyond Earth, we start getting these super Earths, these really large, kind of between Earth and Neptune in size, that might, like be water worlds, be really big objects. And instead, at our solar system, we go to smaller again. And that's kind of odd, because you're getting to where there's more and more and more material toward Jupiter. There's more water available. There's to build these big objects, and it just never happened at Mars. And that's always been a kind of a puzzle. But yeah, we think that they just scattered all the other potential Marses out there and got rid of them. And then your first question, that was too long. I'm forgetting what that was.
The first question was the magnetic core.
That's right. There was a magnetic field at Mars initially. You're right. And we do have evidence of that in the crust left over.
And what is that, usually nickel or something like that, or iron?
Yeah, we do think that the cores of all the, Mercury, Venus, Earth, Mars, the Moon, all are iron and nickel. And there just is a lot of iron and nickel available in our solar nebula. We can see by looking at the sun. We can tell by the light coming out of the sun what's inside of it, which is really amazing. Lots and lots of iron. And where's all that iron? Well, most of it's down in our core. A third of the Earth's volume is that iron core. And we don't actually know the size of Mars's core yet. We have a seismometer sitting patiently on the surface waiting for just one big Mars quake. Can we just get one big one, please? And then we'll get a sense of the size of the core of Mars. But as it is, it's been seeing, the inside is pretty solid. It rings like a bell with the earthquakes that do happen, the Mars quakes that do happen. So it's returned a lot of cool stuff already.
So here's a truly scientific question, and one that's going to take deep thought on your part. Thank God you have advanced degrees and doctorates. So Rebellious Truth wants to know, do alien movies scare you, and do you watch them or do you laugh?
If they're good ones, they scare me. If they've done a good job, then yeah, I'll be happy to be scared. There are a couple that are still waiting. I haven't seen the Europa one or the Moon one they're supposedly scary, but I like them. I think they're really fun. I think the ideas out there are so great. I feel like our universe is big enough that if we've imagined it, it should exist, right?
Why not?
I don't know. Does that make our imaginations too big for the universe? We have to remember that there are trillions of galaxies out there, and each galaxy has billions of stars. And so that's just more than we can comprehend. There's got to be something out there, right? Will we ever see it? Will we see the intelligent life? We're still grappling with this problem that the distances are very big, and we haven't figured out how to overcome that with the physics we know. And so there's got to be some other way. If they're going to come visit us, it's got to be by some other way than we understand.
We need wormholes. Yep. Collapse space so we can just shoot through. That's what we need. Yeah, that's I'm with you. It's we got to have that ability. I'll tell you, the last space movie that really scared the bejesus out of me was not this recent one, which was part of the Aliens sequel. They called Aliens Prometheus, something like that. I think it was a movie. Right. Was it called Prometheus a few years back? When that the guy from Australia, that actor, they I think that was the name of the ship was called Prometheus. Scared the bejesus out of me. That was a creepy movie.
Dude, I need to look for that one. That sounds great.
Oh, it was pretty creepy. And then, of course, everybody, the original Alien flick. I'm sure you know it.
I still can't decide if Alien or Aliens is my favorite movie ever made. It shouldn't say that because I had all the list of other things, Star Wars, Indiana Jones, but those are so good. and I just love them. They're fantastic.
No, the second Aliens is hands down and absolutely amazing. It's the best of that whole series. I'm telling you, I love that Hicks. I don't know if you keep it score, man. We just got our asses kicked. Hicks, calm down.
Plus 5 strong female characters in that film.
That's true. Yeah, that's true. Well, okay, I was going to get to the slides, but since you didn't bring that up, but the kind of good segue to this now. All right, so I have in most of my adult life listened to the story that women and girls are excluded from STEM, science, technology, education, engineering, mathematics. I've heard this over and over and over again. But if we look at the statistics over the last 20 years, the percentage of women going into postgraduate programs is like 60% versus men 40%. And now I'm going to ask you from your perspective, because you grew up in these fields, was it that way at one point, which obviously it was, and did it change during your lifetime? Has it changed? Is it just a myth? Or is the fact that whenever we see scientists on television or at NASA, there are just women everywhere and in positions of authority, positions of responsibility? You look at the Mars mission, women everywhere. You look at New Horizons, same thing. So is the story about women not in STEM no longer true? Was it true from your perspective at some point? Where are we at in that? Because my view is that 20 years ago when people made the argument, I think it was probably still legitimate, but there's still this continuing argument now, and there's this big push to get more women all the time into it, and they're neglecting boys from my standpoint. I mean, we should encourage everybody to get into STEM.
Yeah, I mean, I think, so I'm a teacher myself. I teach university students, and yeah, from my standpoint, I think it's valuable to get everybody in and also just make sure that it's a good environment for all kinds of abilities, because if we kind of restrict things to, well, you must do things this way, then you're going to exclude somebody. And that started with, from my perspective, like, well, there aren't a lot of other women in my class. Am I going to be able to do okay? You kind of look around and see what's there and see if there's anything like you. My professor's not like me, and these other students are not like me. And so, but then I realized kind of by the end of my undergraduate, which was in physics at BYU, Brigham Young University, my class was actually a third women. And I sort of got lucky that happened at that class time and then didn't happen again for quite a while after that. And I think probably still hasn't happened. There are a couple of fields that are still quite low. Physics is very low. Engineering is always quite low. Things like geology, we're a little more like 50-50. Biology is probably more women than men. And we still are trying to figure out the psychology of that, what draws women to those particular disciplines more than others. And so, but I think you're right. What about people who learn differently, but they could make really great contributions? We just need to make sure that it's a good, nurturing environment for everybody and continue to get the numbers up. Where it doesn't trickle up is into the college professor level. And those are the ones who are teaching you. And again, you look to them like, is there somebody like me? So we still want to work hard toward getting women into those jobs. And I think that makes a big difference.
But you are teaching at the university. You teach freshmen. Yeah. I think you teach upperclassmen, and you also do graduate students as well.
That's right. Yeah. So, yeah. And right now I am the only one in my department of geological sciences. We're about 13. And so we're still working on it. We're still trying to get more and more here. I think from my standpoint, I think I was lucky in that I did have some good mentors early on. And then also I just was on a path. I was like, I don't care. I'm going to go to space. And so here I go, and I got lucky to be able to do those things. The doors opened and things worked out for me. So that's been really good.
Well, you've got, real quick, just a little housekeeping. Hey, folks, you're listening to Chris Wyatt Africa here on the Indaba Broadcasting Network on YouTube. My special featured guest today is Dr. Jani Radebaugh from Brigham Young University, a planetary scientist. We've talked about all the things she's involved in and only scratched the surface. There's much more. So you can go back and watch the stream from the beginning if you like. But you've got some really interesting slides that you popped up on the screen beforehand. Can we spend a few minutes going over that? Can you share that with us?
Yeah, I'll show you just a couple things here that I think you'll find interesting. I may show, let's see right here. I'm going to jump around just a little bit, but I know your audience is a lot of you are African or are fans of Africa. So just to make you maybe like Ethiopia a little better, Chris, just kidding. I got to go to a region that's called the Afar, and I am fascinated by this area. It's up in the northeastern portion of the country. Yep. And look at this is totally alien. This is my friend David, who's trying to breathe because I forgot the gas mask in the car. But it's a really kind of sulfury area. It's a hydrothermal region like Yellowstone National Park or Taupo in New Zealand. You can see the yellow way behind. But this is iron covering salt. in this region. So there are these salt flats that get uplifted, and they're uplifted because there's a volcano here. So here's the edge of a volcano. This is called Erta Ale, and there's actually a village right here. Can you imagine living in this village? I mean, it's really difficult to even get around. I guess you can make pathways through this rock, but it looks like they just get used to walking across the volcanic rock.
That's just basalt, right?
It's just basalt, and it's erupted out of a big, broad shield volcano. But there is a lake of lava erupting out of the top of this volcano, and so we go and look at that.
So
there.
What do these people eat? There's nothing growing there.
Yeah, they're sort of gatekeepers at this outpost, and I'm hoping that this is just sort of an outpost. There's a more kind of clement village that's down the slope where I think most of them live. We get permits there, and then we collect guards to take us up the mountain. It's near to Eritrea, and so there's a little bit of I guess tension, but there's a lot of tourism here now all of a sudden. And so lots of people want to come up and see the hydrothermal area that's so beautiful, the Dowlal, and they want to see Erta Ale volcano. But I really love it. Here was my guide. He was probably 14. I didn't know this because we hike up the mountain in the dark because it's very hot. It's really low, and it's always 100 degrees Fahrenheit. So we walk up at night, and I was like, can you tell the guide to slow down? I can't keep up, and he's probably this strong, 25-year-old. He's 14, and I can't keep up with him. He does this every night, and that's his job. And I just thought he was such a sweetie when I saw him the next day. And then also people really let us feel like we're helping and we're part of this. Can you guess what they're carrying? I don't know if anybody online can guess. This is a real trade. This isn't just tourism.
It's salt.
Salt, very good. So they've got these vast, massive salt flats. And there's a very active salt mine that's going on. They chip these blocks out by hand, put them on the camels, and march them 7,000 feet up to the village at Mekele and trade them there. So they were like, okay, you take your picture, make it quick, But it was just fascinating to be there. I really, really love going to Ethiopia whenever I get a chance. Okay, and I'm also going to go, I just keep jumping around a little bit here, but I want to just show place that we like to go visit. This is up in Argentina. Okay. And in Argentina, am I still sharing in this one? Do you still see?
You are. I can still see it. I got two pictures there. It looks like gypsum.
Yeah. So in fact, this is volcanic ash. Isn't that amazing? It does have that texture. But these towers are, you picture that this entire landscape was blanketed in a uniform layer of that ash. The ash is about 80,000 years old is all. So this was a super volcano that erupted 80,000 years ago, way up in basically the Altiplano, Puna region of Argentina. Mm-hmm. And then it was eroded constantly after that by wind. There's been some episodes that are a little bit wetter than others, but not really. I mean, this area is basically just wind. And you can see big gravel ripples out in front that just tell us that, hey, the wind is in charge here. Here's an example of that. It's just really smooth. It's been carved by the wind. The gravels have been blown up into here. We just love this as an analog for Mars.
That's insane. That's absolutely insane.
Yeah. And we even see landforms that are a lot like this on Mars. They're just regularly shaped wind carved ridges. My friend Laura would love to build a habitat on the inside of one of these on Mars, right? Hide you away from, you've got a natural sidewalk already. So anyway, I really love being there. It's actually, when I've got a student, I bring students with me, and Jonathan here is measuring a harder rock protruding out from the softer rock, and you can tell the wind directions that way, which is pretty cool. So
because it's blown it away, and that's the resistance of the wind.
Behind all the soft stuff, exactly. So we're kind of starting to make models for how the wind flows over these ridges and getting the hardnesses of the rock and things like that. Here's a little model for how it flows, and see the recirculation on the back, which is pretty neat.
That is pretty
cool.
So
the same kind of thing we think is happening on Mars. We also asked, gosh, does the wind get very strong here? And yes. A couple windstorms.
Wow.
More than head height.
No wonder there's so much erosion. Oh, look at that. That looks unpleasant.
Yeah. I was like, it's funny to be a wind scientist because you battle being annoyed by the wind with, oh, quick, get all the instruments out and measure everything. And, oh, yeah, it's hitting my eye. That's so cool. It's getting that high. So anyway, it's a strange thing. Oops. But then also we brought our drones.
Oh, you guys are in love with those drones.
We love them. They're so great. And here you can see this really undulatory landscape. We see a lot of these things, periodic ridges all across Mars. And we're still trying to kind of figure out how they form. How are they like those isolated mounds? Are they the beginnings of the isolated mounds? Are they the ends of them? What's going on? But it's an utterly alien landscape, right?
Wow.
It's
Are those little specks of those rocks, or is that some kind of vegetation?
Yeah, that's more gravel. I mean, those gravels get blown all the way across that stuff. I guess probably during the winter. We're always there in the summer when it's a little nicer, and even get those windstorms in the summer. So maybe they get really crazy in the winter. Wow. Or they're just eroded out of the rock and are left behind. That's the other thing that can happen.
That's
but I might. Oh, go ahead.
No, I said that's astounding. Now, in the distance, is it just optical, or are the mountains in the distance beyond the ash flow, so they're a different color?
Yeah, they're beyond the ash, so they're a different color. So yeah, we do see the end of that ash and the beginning and the end. It's only about, where we study it, only about 10 kilometers across. So it's kind of, we can get that within our minds and understand it pretty well.
Wow, that's amazing.
Yeah.
So many deserts on Earth, the Namib, the Kalahari, the Gobi, the Atacama. Jeez.
Yeah. Oh, here's a picture of the sand dune we studied in Namibia. Mm-hmm. Sorry, I only have this picture of Namibia, but you can kind of see, oh yeah, this is a pretty tall sand dune. It took a little while to get up here and then get all the way back down the other side. I really love the color of the dunes here in the Namib, this beautiful deep red color. It's just fascinating. Gorgeous.
Of course, the hard part too is that as you step, it collapses around you, so you got to put a lot of extra energy.
One step up, two steps back. Yeah. Hopefully it's two steps up, one step back.
Exactly. Otherwise you'd be spinning your wheels, literally. Now that's an amazing shot there.
So I could finish on one video here that's about another kind of exciting. Oh, well, let me show this one here. This is the little helicopter on Mars. This one's called Ingenuity.
Yep.
And this is some video of that thing just taking off and lifting up off the surface. You can see that. That's kind of fun. I think it's all done now. It just had a battery, and so the battery ran out, but it did a couple of little test flights along the way, and that's pretty neat. So there's the Mars helicopter. Here is the Titan helicopter.
Dragonfly.
And it's called Dragonfly, and it's approved. It's a new frontiers mission, and it's being built right now at Johns Hopkins University Applied Physics Laboratory in Maryland. And it is about the size of a Mini Cooper. So kind of picture that. This is big. Yeah. But not only is the pressure of Titan's atmosphere at the surface like Earth's, it's 4 times as dense. So I always feel like, would that be like walking through a down pillow? What would that be like? There's a lot of atmosphere, which makes it very easy to fly in. And so what we have here is basically, it's an octocopter, and it can pick itself up and fly across the surface and then land, and then pick itself up and fly again. So here's a little animation of what will happen. It will descend through the atmosphere, take about an hour and a half to get down a ways through the atmosphere, and then get released and then fire up. This is the nail biter part, right? It's got to start working. It's got to start flying, and then just find a location and safely land. It will overfly a new location so that we can kind of see what the next place will be like. But the first one will be a little bit blind.
So they're going to launch this thing in mid-flight, hoping that it flies.
It's communicating direct to Earth with that dish.
That's interesting. Interesting, yeah. Because with Ingenuity, of course, it was on the bottom of the rover. We landed, and then we released it. Yeah. That's unbelievable. That's really exciting. Now, okay, so with planetary rotation and with construction underway, is there a projected launch date and then an arrival date?
Yeah, we have a launch date now of 2027, and I don't know if we have an actual date then, but we did just get approval to launch on a heavy rocket, which is really helpful because the bigger the rocket you can launch from Earth on, the faster you get to the outer solar system. Mm-hmm. And so this shaved a few years of time off for us to get out to Titan. So we'll launch in 2027. We'll arrive in 2034. So it's exciting. It's going to be a while. I start adding up. Just don't do it yet. Don't add up, the years. But we are on our way. We will get there.
Wow.
And it's really great because we'll bring with us a mass spectrometer on board, which means we can actually suck the dune sands. These mountains you see behind us are sand dunes. Mm-hmm. We're going to land in the sand dunes and draw that organic material up into the belly of the spacecraft, analyze it, and tell exactly what those materials are made of. And we can even look for, evidence of chirality, for example. There's a left-handedness to all the organic molecules on Earth that are manipulated by life. And so we can tell that something has organized them into that left-handedness. And so we can even look for things like that, which is really exciting. We can look for evidence of the possibility that life has happened elsewhere in the solar system.
Well, I'm liking that. I'm left-handed, so it sounds good to me. I think with the right side of my mind. This dragonfly is pretty impressive. Ooh, look at that.
Oh, yeah. Sorry, that was Titan. And now I just escaped out of it.
That's from Voyager. Speaking of which, Voyagers are still out there flying through space.
I know. Isn't that so exciting?
It's unbelievable.
It's amazing. Yeah. And they're still communicating with us saying, okay, we just left the solar system, just letting you know, we're out in outer space. So
yeah, are both of them outside the heliosphere or just the one?
I think you're right. I think I was just aware of one, but I thought I heard something about maybe the other one has. It's sort of a fuzzy boundary.
Fascinating stuff.
Yeah.
Now, so Christoph is asking who's going to launch it, but I don't think that will be decided at this point. She's asking
SpaceX.
We don't know. It's SpaceX or ULA. I mean, it's off in a distance. There might be another competitor that comes along that does it. But it is interesting, this private-public partnership aspect. And SpaceX, whatever people think of Elon Musk, you got to say the guy had a vision, and he really pulled off what he said he wanted to do in less than 2 decades. I mean, reusable rockets. It's unbelievable.
Yeah. I think that what he's done is just really important for space because he's stretched the boundaries and said, hey, there's some things we can do. I really liked Jim Bridenstine as the lead for NASA because he grabbed onto that and said, hey, get us some rockets, get us to space, get us up to the space station, and really was a proponent of them helping out. So and then Blue Origin is coming up soon. They're going to do a flight, and a number of others are. I mean, it's just a great time to be doing space right now. I just think things are moving forward at a great pace.
Well, there was a time when General Bolton was the director of NASA, and the focus seemed to be on unmanned missions, which are cool. I mean, they're awesome. But the manned space flight seems to have come back in vogue, or at least that's the perception from outside the community. I think that's pretty exciting. I mean, Musk is pushing for Mars. I won't be on the first mission. I'll volunteer later on. Let's get proof of concept first. I've watched Starship 1 through 8 go up and come down like Roman candles. So I'll wait a little bit longer.
We'll be among the first 100, right? It'll be
exactly. And then Christoph Avanga told me, he said, Chris, Voyager turned into AI. Didn't you watch Star Trek? Yes, I saw V'ger. Did you see that Star Trek where this alien presence, it's a ship and it's menacing. It turns out it's Voyager, but there's debris on it, so it covers up part of the name and says V'ger.
That's awesome.
Takes them a while to figure it out. But clearly, you obviously truly enjoy what you do. That's awesome to see.
Yeah, I mean, how lucky are we to live right now on planet Earth and see everything happening? And I think that's true for everybody. All of us are participating in this because we can see it happen. We can see, oh gosh, now, China's got a lander on the surface of Mars, and the United Arab Emirates is orbiting, and India's got another craft. I mean, it's so great to be alive and see what's happening and feel like we're really doing it. And I feel just absolutely so lucky to do what I'm doing. Really,
well,
really
having worked in intelligence, been in the military, I thought it was pretty exciting when Mosaic, Mark Anderson and the University of Illinois Carbondale came out with Mosaic in 1994, and then we went to the web browser based internet, because I mean some of us have been on it prior to that, but in a different fashion. But it was so much easier than typing in // it was so much easier. but I thought that was exciting. And I thought the advent of GSM communications and then Thuraya handsets, and I thought all that was cool, and e-commerce and everything. But we throw all of the space exploration has come about, the development's taken place in the last 10 years especially. It's just unbelievable. It's a fascinating time to be alive. The unfortunate pandemic nonsense aside, all that aside, it's a really fascinating time, I think, for humanity just to be alive.
Oh yeah, I agree. And in some ways, all the bad things that have happened with the pandemic, I hate to minimize that, but for me, I guess even the getting married and everything, just sitting down and kind of saying, okay, what do I want to do? And I think maybe all of us had a little bit of a moment with that. What do I want to do? I've got time to sit and think about it. And that's really valuable. I almost wonder, every 10 years, can we shut down? Let's just do it a couple of weeks and just everybody sit down for a minute and have a thought. And, I just to slow down for a second, I think that was a value, but we're all ready to get back and get going again. Right. And just, plus just get this out of the way so that nobody else can get it. I think that would be great.
Well, I don't want to be selfish and keep you here for hours on end. It sounds like we could talk for hours, but we'll go just a little bit longer if it's okay with you, Jani, just to wrap up a few things. But I do have a couple questions. So How the Universe Works, one of my favorite all-time series of all time.
Oh,
And I'll be interest of full disclosure, I'm biased. When Mike Rowe narrates, that's when I really get excited, when Mike Rowe's on.
Oh, yeah, he's so good. Yeah.
But you're a frequent contributor to that program, along with Phil Plait and Mugeka Cooper and Hakeem and all these other people. How did that come about? Did they just reach out to you because you're well-published and well-known in the community, and did you get involved with that?
It turns out my friend and colleague, Ralph Lorenz, has done a fair amount of TV. And they asked him to help with the show back in season 3, and he was unable to go. And he said, but hey, you should contact Jani Radebaugh, because the two of us have traveled a lot and collaborated on things. And it's been a good mentor to me. And so they did. And then when I came on with them that time, then they've asked me ever since. And Ralph's like, oh, I can't believe I didn't go. So yeah, that's a little bit of a thing. But yeah, I'm so grateful I've been a part of that series. It's so fun. And I think they do a great job presenting the science. I even love the kind of out there ideas that always come at the end of the episodes, because it's mind opening. There are a lot of things like, well, we don't know this yet, but it's great to think about it and just see where we're going to go. I just hope this series continues. It's one of these, I really feel like the last, 5 to 10 years of science documentaries have just gone through the roof in quality and just viewership and everything. It's another aspect of the fun time to be alive.
Well, I would absolutely have to agree. I mean, that's a brilliant show. There's other shows that have been similar, and some they've tried to, I don't want to say compete with, but try to match. But I don't think any show really for that sort of genre is ever been able to match it. It's really fantastic. And to be fair to both the folks who narrate the show, they're both fantastic. But I really enjoyed. Also, I like how you bring back familiar faces, like you come back frequently, and there's other people come back frequently. But also they bring new faces in that some people are not familiar from the community, which is pretty cool. It's good.
When they need expertise, they get the new experts, and yeah,
it's awesome. A pretty awesome show. But you've also done TED Talks, you've done Nova specials too.
Yeah, and I did Unexplained Files, and that was kind of fun too. Everything has a little different flavor, and it's fun just to get on and try. And I think I was talking about an alien spaceship out at Pluto on the Unexplained Files, so that was pretty good. That
wasn't with the guy with the hair, was it? The crazy hair. You know what I'm talking about?
I feel like that's true. It might have been on that episode. I don't know.
I saw him on it. Oh gosh, what's that show with Alan Tudyk that was on about the alien who landed on Earth out there? Oh gosh, what is that? It's a new show. It came out this year. I can't think of it. Anyway, but Alan Tudyk, because Firefly is one of my favorites.
Great. I love him. I know, me too. He's so great.
You like Firefly?
I love Firefly.
Oh
yeah.
My God.
Plus, I'm a big Nathan Fillion fan. My friend manages him, so I think he's great.
No, Nathan's awesome. The only show he ever did that was kind of made me scratch my head was that show called Cars or something like that. It was like they were racing across the country, but two guys, two gals in a pizza shop. I've been following him since back then. And Castle, I was a huge fan of Castle, although the last couple of years I could have done without.
I know, Castle was so great, and I watched the rookie. I love it. He's just really fun, and he's got the new what is it called? The new superhero movie coming out pretty soon.
Oh, anyway. Does he? I hadn't seen that. Okay.
Yeah, not the Untouchables. I'm a terrible superhero.
Something anyway. Like that. But no,
someone knows. Type it in.
Someone in the chat might know, but Firefly was just that show. But Fox just didn't. That wasn't fair. They started with the third episode. Confused everybody. Then the baseball playoffs were there, and they canceled shows, and then came back. And anyways, but when it came out on DVD, it became the best-selling television series DVD of all time in a matter of like 3 months. Now I don't know where it sits now, but it was the best-selling ever when it came out. I have it on Blu-ray. I have it on DVD. I've watched it 1,000 times. I went to the movie Serenity 6 times just to drive up attendance figures, hoping that they would get another one. Josh, what's that?
They still have a massive Comic-Con following when they get out to it, and they love going. I think that's so fun. It's really great.
Have you been to Comic-Con? I've never been to one of those.
No. I do go to convention. It's called Space Fest. This is really pretty neat. It's held in Tucson every year, and Apollo astronauts come out to this. I don't know how many. I mean, this is a gold mine that you still can have Apollo astronauts come out to things, and they come and sign, and they talk, and they do panels. It's really spectacular. It's run by a gallery owner called Nova Space. Mm-hmm. And it's a fun, it's kind of small, but there's lots of international participation, and I really love it.
That's pretty cool. It's I'll have to check into that. I was unaware of that one. That's pretty interesting. Okay, so this is probably the most important question I ask of you this whole conversation. Big Bang Theory. Fan? No?
Oh yeah, totally. I love it. It's so fun.
Okay.
I belly laugh at every episode. It's really fun.
I've watched every episode probably 50 times. I put it in the background because I unlike Microsoft, I can actually multitask. So I usually put on the background when I'm working and that sort of thing. But yeah, I know the whole show is just brilliant. I love it. It's what I love about Big Bang Theory is for people that aren't into science or aren't into astronomy or physics and things like that, they make the jokes, they make it relatable that people that don't even get, they kind of get it, and it kind of brings you in and makes you think about those things. And my favorite was when Wallowitz went to space. That was pretty cool. I really enjoyed
that's so fun. Well, and I think it's helped to normalize these personalities too, that we've been talking about, that you don't have to fit some mold. You can be a little bit different, and in fact, if you're a little different, then you're special. And I think that's been such a good outcome of it.
So I think the Big Bang Theory legitimately, at least in popular culture, made geek chic.
Yep, exactly. It's so fun.
Well, listen, like I said, we could talk forever. Maybe I can invite you to come back on the program. I may get your friend Lauren or someone to come on. We could chat again. But Dr. Jani Radebaugh, I want to thank you. Any last thoughts or things we should look forward to look out in the near term, or something you just want to share with the audience?
Gosh, I'm trying to think of what's coming up. There's always something coming up. And
that's true.
I open up the phone and look every day. It's just an exciting time, honestly. And so keep your eyes open for what's coming up. Keep your eyes on that volcano. Look up active volcano Iceland. You can find a live feed of it and feel like you're standing there. That's another crazy thing about the internet, is that there's a camera broadcasting an erupting volcano on Iceland, and you can go and look at it anytime you want. So I've been doing a lot of that.
Well, that's a good point. It's a while back. It's not so much the norm now, but when about 10 or 15 years ago, webcams, fixtures and traffic cams became something you could just start watching online all the time. And I'm a big fan of the Faroe Islands. I've been to the Faroe Islands as well as Iceland. And there's one there in Tórshavn. Used to have so when I was prepping for my trip to Tórshavn, I'd just check the webcam every day and see what's going on there. And then when I was in Tórshavn, people were like, "You're where?" I'm like, "I'm in the Faroe Islands. Go to this website and check it." And I stand in front of the camera waving to them. But so there's a webcam in front of that volcano now. That's interesting. So.
Yeah, they have to keep moving it because the lava keeps moving around. So hopefully they've got it in a place where it's facing the eruption right now.
Leovin Janssen von Runsberg, she's in South Africa, and she says, "This is awesome. Love how excited she gets. Almost excited as Chris."
I don't think I can match you. I don't know if I'd even try.
Well, it's the enthusiasm. It's good. You got to have enthusiasm for life. Otherwise, what's the point, right? Anyway, exactly. Dr. Jani Radebaugh, thank you so much. If I could ask you, if you don't mind hanging out for a few seconds while I close out the show so I can chat with you real quick, just stay on the Zoom. Is that okay? Okay, cool beans.
Nice to see everybody. Thank you so much for calling in.
All right, cool beans. All right, that's Dr. Jani Radebaugh from Brigham Young University, ladies and gentlemen. Let me get her in the waiting room. I got to get to my Zoom session here. I'll put her in the waiting room, and I'll do that myself. Whoops, what's going on there? There we go. And I'll be with you in just a moment. There we go. All right, folks. Dr. Jani Radebaugh, that was amazing. I hope you guys enjoyed it. Pretty good audience for that. Really appreciate everybody tuning in. This is pretty cool. I've been hoping to get folks involved in this field on the channel for some time. And, we do a lot of reporting here on space events, particularly the stuff related to SpaceX. But not just SpaceX, all the things NASA is doing, and the European Space Agency, the Japanese Space Agency, and others. Thanks a lot, folks, and my special thanks to Dr. Radebaugh, Jani Radebaugh, rock star. I promised you guys a rock star. She's amazing, absolutely amazing. And I'm sorry, Christoph, she's married, so you're going to have to look elsewhere. Anyway, folks, thanks. God bless. Have a lovely day. I'll be back for Night Owls in a couple of hours. For this evening, we'll do a wrap-up of what we discussed today, and we'll bring you an update on the Indaba African news of the day, events taking place across Africa, and for those who influence the continent. And with that, out of here, folks. God bless, and have a lovely day. Hopefully, we'll see you on Night Owls.